tutorial, I will be showing you how you can find the mean, mode, median, and standard deviation of a normal distribution. And I will be showing you how you can graph a normal distribution and find the information using Python. Let's imagine that in a city of population 66,000 people, we have this normal distribution of the ages. This bar here is the people, all the people aged from 0 to 5. This bar here is the people aged from 5 to 10. And going up here, we can see that most of the people in this city is aged from 30 to 35. Now, it will just be like this bell curve over here, as you can see, where only few people are newborn, and few people are aged over 75. How will we find the average age of that city's population? The average age is all of the population's ages plus together divide by the amount of people in that city. The mode is the most frequent number appearing in the list of ages. So you can see here, the mode is somewhere between 30 and 35. And to find the median, you list all of the ages in order, like from least to greatest. And from that list, you pick the number right in the center. Now, what is the standard deviation? Over here, I have this formula. Mu stands for the standard deviation. Over here, you can see. And the formula is the square root of the sum of all the values, subtract the average age squared, divide by the size of the population. Now, over here, we have this skewed deviation. You can see that the mode is this point here, so this number is most frequent. Here you have the median, so it's when you list all of the values, you pick the value in the center, and in this case, the value in the center is between 4 and 5. And the mean is the average. So if we add up all the numbers and then divide by the population amount, we'll get the mean. This is a skewed distribution. Over here we have a symmetrical distribution where the mean, mode, and the median are all the same. As you can see here, this is a standard normal distribution. This point should be the average, the mean, and this place should be the mean, mode, and median. From here to here is one deviation, and we have 68% of the area covered by negative mu and positive mu. Here we have negative 2 mu and positive 2 mu. Now let's have a look at how we can find this information using Python. First, let me run this. Here I get this normal distribution. Here I get some values, and I will show you what they are later. First, I import matplotlib.pyplot as plot, and I import numpy as np. X equals to numpy.random.randin 100,000. This will return a list. This will return a sample from the standard normal deviation. So if I print this, this would be a very long list containing 100,000 numbers. Now let's go back here. X this equals to numpy.linspace -3, 3. This will return a list containing 50 numbers starting at -3 and slowly adding up to 3. You can change the amount of numbers in that list by simply saying num equals. Here, if I say 1,000, each number will be closer to each other. There will be 1,000 numbers in the list, slowly adding from -3 to 3. Here I define my bell function. The function of a bell curve is 1 divided by the square root of 2 to the pi power times the exponent of, here we have -x squared divided by 2. And for a normal distribution, the area under this curve has to equal to 1. So to test whether this function really is the function of the bell curve, we can find the area using integrals. From SciPy dot integrate import quad. Now let me print the integral of that function. And I want to find the area starting at -3 and ending at 3. Now I'll run this. Let me see here. Oops, I forgot to pass in the quad. Here we get the area is rounded to, if you round this, it will equal to 1. Since this is not an exact this is not an exact normal distribution, here it's a little bit random. And this is simply the error, which is 0.0000, very small error they give us. So now we know that this really is the function for a bell curve. Now I simply numpy.medium, I pass in any list and they will give us the medium of the list. Here I pass in any list and it will return the mean of the list, and this will return the standard deviation of the list. plt.plot, here I put in this list here and the function, and this is the line's width. I don't really need this. Oops. Here we get this nice bell curve. This is the end of this tutorial. If you have any questions, requests, suggestions, or comments, please leave them down in the comment section below. Today is February 5th, 2020. Please hit the thumbs up button if you enjoyed this video. Please subscribe to my channel. It's called NetsEDU. Thank you for watching and have a nice day.